Hello, it's John from Gold Coast Trade College, just bringing you unit AURET003, identify automotive electrical systems and component. So to run through on the electrical componentry, wiring, give you some understanding of the basics of electrical system in a car. The course objectives pretty much laid out there. Always a bit more difficult to understand it without some props, without actually feeling, seeing, having to wait, showing you the location of some of this componentry. So it's the theory component today, and it really does give you the basics to understand it when we get you doing the practical. But you'll understand from the technical information where we go to next. Okay, a bit of safety. Obviously, steel cap boots. That's your PPE. Follow instructions from people, whether you're in the workplace, school area, or in our workshop. Health and well-being, you got to look after number one, yourself, but also be looking after other people around you. Use the correct equipment and tools correctly. Manual handling, be aware you may be lifting, a battery, an alternator, some heavy componentry. You might be twisting or turning, lifting up, pushing down, all sorts of angles and things that you may get yourself into with different weights, components. Keep others safe. Look out for one another. That's your duty of care. Very conscious of workplace health and safety as we work our way through this. Let's go to some general items about the electrical system in an automotive vehicle. Electricity is a form of energy called electrical energy. Can't be seen, heard, smelled or touched. However, the effects of energy can be seen, heard, smelled and touched. For example, light bulb, lightning, a heater and some burnt wires. Let's have a look at the electrical symbols that we'll run into, and these are used extensively in wiring diagrams, and sometimes, or most of the times, they're stamped on the components as well. So the terminals and things where you're running wires, they will tell you via these symbols where that wire goes to. Starting up in the top left-hand corner there, we've got the ground or earth electrode, antenna, battery, source, a constant voltage, which is like a battery symbol, fuse, inductor, a motor, easy to remember that one with the large M in the middle there, the bulb, and then we go to the top right. We've got the transformer, coaxial plug, a switch, resistor, capacitor, diode, and a diode LED. So that's the symbols you'll run into, and there are many more. Let's have a look at the terms that they use around them. The electricity cannot be weighed on a scale or measured in a container. But there are electrical actions, and these are the terms we use: voltage, current, resistance, and power. Voltage is the pressure, current is flow. Typically, the current flows from the positive side of a battery through the circuit, returns to the negative or ground earth side. Remembering what a battery looks like, two terminals, one larger than the other. The large one is the positive, usually indicated by being red or having a red ring around it, with a positive plus symbol beside it. Negative, the larger, the smaller of the two, it is black in colour or has a black ring around it, and has a negative minus sign beside it. Easily recognisable positive, negative terminals on a battery. Resistance opposes the flow. Power is the amount of work performed. And then it says there, think of a hose with a sprinkler. So they're talking about a circuit. And if you think about a car, there are many, many circuits, okay? And many different bulbs, switches, lots and lots of things to sort of think about. We've got bulbs, lights at the back, at the front, dome lights in the middle. We've got switches around the place, in the boot, under the bonnet. We've got some cars with batteries in the boot, some in the front. So there's a fair bit to think about and learn on this. Let's have a look at the electrical charge. Okay, it's the movement of electrons. Okay, creates the charge and it does all the work for us. Turns on those light bulbs, charges the mobile phone, stereo, radio, all that sort of thing. That's what's powering a lot of those nice accessories and luxuries we have in modern cars. The three basic principles are voltage is the difference in charge between 2 points. Current is the rate at which charge is flowing. And resistance is the material's tendency to resist the flow of the charge. Current, okay? They're the three that sort of get tossed around the most when you're around electrical components and working out voltage drops and all sorts of things. Okay, so let's go on to a little bit of history and we'll find out how all this started and some of the terms. Ohm's Law, by that picture there, it must be older than me, this guy, just fractionally. Ohm's Law states that 1 volt is required to push 1 watt through 1 ohms of resistance. Okay, it's a mathematical equation. We will look at it a little closer down the track. To the right there, you can see Ohm's Law, the equation I equals V over R. And above that is a little bit of the symbol there of how he got to it. Moving right along, there is a couple of these laws that you have to have some insight to, and they do help you as you work through the mathematics of it. James Watt, born on the 30th, yeah, he is older than me, there you go. Okay, Watt steam engine, 1776, which was a fundamental to the changes brought by the Industrial Revolution in both his native Great Britain and the rest of the world. So Watt's Law, P over I over V, okay? You'll see how that's used as we progress through these slides and as you progress into working out electrical wiring circuits and things. Typical current flow, got our battery there, the negative and positive. From the positive, we've got power running along up into a fuse protection, a lamp, light bulb, it's the load, and then we've got the switch or on-off control, and that goes back to the body or frame, which is the ground, which runs back to the negative. So opposed to perhaps just comparing it, not voltage-wise, but comparing it to circuitry in a house where you have the positive and the negatives and you run it back to ground, you have to have a return wire. In a car, use the metal of the car body as the ground or body, okay? And we'll get into that as we go along. Voltage is electrical pressure, like a pump that pushes current through the wire. So a voltmeter measures the differences in electrical pressure between 2 points. You can buy voltmeters, amp meters, whichever you want to call them. Usually they're a multimeter, another term for them, and it measures a couple of those different measurements around electrical. So moving right along, let's get to understand what we can do with this voltmeter, amp meter, probably multimeter is the better term. Voltage, here we have the voltmeter with its negative and positive connected to the battery. It's registering 12 volts. Down the bottom, we've done a similar thing. We've got it on the negative and we've got it connected to the wire or touching the wire just before the light bulb. And we're still getting 12 volt indication there. So the current is the electrical flow moving through the wires. Current flows in a wire pushed by voltage. Current is measured in amps. The amp meter measures current flow in amps and is inserted into the path of the current flow. So you'll find, and I would think some of you have probably seen these multimeters, the next diagram here has pretty much what I was just about to talk to. You can see the red and black, negative, positive. These little tools, little pointers, actually usually sharp and can penetrate the insulation of a wire, so you can actually get the multimeter to read up on the diagram there. You can see I've got it on amps, but there are a couple of, just by moving the little switch around, you can change it to volts, ohms, all sorts of things. All right, very straightforward current there. You've got the battery, and they've actually used the voltmeter or multimeter there as a switch, because they've actually connected the negative and positive of the battery via the lamp with the use of that multimeter. All right, resistance, and there's the symbol for ohms at the top there. So it's a measurement, remember, of the resistance. Resistance opposes the current flow. Every electrical component or circuit has resistance. It's not built in, it is just the way, it is a measurement of that resistance through the thickness, the length of the type of conductor that you're using, whether it be copper wire or something else. The resistance slows the flow of the current, changes electrical energy into another form of energy. That could be heat, light, or motion. Resistance is measured in ohms. As I said, an ohm meter is used to measure resistance of a device only when there is no current. So we're actually not measuring any current going through it. We're measuring what is going to resist that current flow. The term, thank goodness, it's pretty much self-explanatory, which is a good thing. Resistance. So they're measuring a carbon composition resistor. I won't go into what they're used for at present, but we'll get there somewhere down the track. So there's our multimeter again. As you can see, the little switch diagram in the middle of the multimeter is pointed up to the ohm symbol. So hence it is reading in ohms. Once again, red and black. What would you call them? I don't know. They're a tool with a sharp steel pointer coming out of them. Allows them just to, because they're so thin, you can direct them very small contact points on what you're trying to measure. Works very well. Been around for a while. There we are. Ohms Law triangle. So you can see how that is used if you want to work out the voltage, the resistance, or the amps. Okay, voltage, amps, resistance. Just works off that triangle. Just move them around and use it that way. Power, which is watts. Watts is the unit of electrical power. This is found by multiplying the voltage and the current. The power of any electrical component is expressed in watts. Now, you know, this is used not only in automotive fields, but watts is also used in 240, three-phase, all sorts of other electrical motors expressed by watts, you know, how much power it takes to turn. All right. The wattage of a light bulb are a perfect example. Okay, and that's how you work it out. Volts, watts, 1 amp equals 12 watts. All right, very straightforward, just a bit of multiplication. Electrical circuits and components. Electrical circuit is closed path through which current electrons flow. Okay, so talk about open and closed circuits. An open circuit is one that's got a switch in it. The switch is open or off. If you want to close it, turn the switch on and that completes the circuit. The basic practical circuit contains the following: a power source, battery or an alternator, device or load. That could be headlights, starter motor, fuel pump. Cables and connectors. Cables conduct the current. Terminals make the connections. Control devices. Switches and relays, which can be controlled manually or automatically. Protective and safety devices. Fuses, circuit breakers. We still have a number of fuses used throughout the automotive industry, although circuit breakers are becoming more the common and more the norm now. Control devices, a lot more relays being used, a lot more power sensitive, current flow sensitive devices in cars. So let's have a look at some of the basic electrical components. Switches turn the circuit on and off, close and open, as I said. Relays, electromagnetic switches. We're hoping when we get you into the workshop that we can actually get you to wire in a relay, and you'll see how, not that involved, but once you get the idea, it's pretty straightforward and you'll understand how it assists. Solenoid, electromagnetic coil with a movable core, very prominent, and the first one that jumps to mind is in a starter motor. a solenoid and has been for years. I can show you those. You'll see them being used quite easily when you have a look at a starter motor. Fuses, usually a fine wire or soft metal that breaks when too much current is drawn. So it sort of burns it away, and then you have an open circuit, you don't have current. It's done its job. This protects the circuit from overheating and catching fire. Have to be replaced once blown. Circuit breakers do the same job as fuses, but can be reset and used again. Usually just a small button, you just push, clicks, and away you go. More and more so being used. Basic electrical components, a basic circuit. So there we have a battery with a positive and negative terminal. Very simple. Looks like something you get in a torch. And you have the circuit running from the positive up to a fuse, across to a switch, which is currently open, down to a light bulb, which is the load, then back to the battery, the source of power. Parallel and series connections. Okay, series circuit. One blown bulb will stop all bulbs working by breaking the circuit. So you can see we've got 3 lights in a series, 3 bulbs in a series. We've still got a battery positive running up to the switch, which is closed. Then you've got 3 bulbs in a row. Okay, that's series. The parallel circuit, if one bulb blows, the other will continue to work. Automotive lights are in parallel circuitry. So if we went back and had a quick look at our series circuit, where we've got the 1 wire connecting the 3 lights, if the first, second or third bulb should blow, then the power can't keep flowing around the circuit. It's then open, similar to opening a switch. So series has a bit of a fault in it in some ways, although it is used sometimes to indicate that there is a fault. Horses for courses. All right. Back to our parallel, you can see there very simple explanation of parallel and series. Bulbs are in a series. These are parallel to each other. You've virtually got 2 circuits there. You've got the top one with the bulb and the bottom one. The top bulb blows, the bottom bulb is going to continue to light because the current can flow through. Okay. Used specifically from some circuits for safety, but also it's horses for courses once again. Okay, basic starting system. Starter motor circuit sends current directly from the battery to the starter motor to turn the engine. It uses a switch, a relay, and a solenoid to do this. The key switch acts as a remote to operate the relay that sends a current to the solenoid on the starter motor. So the solenoid is that large circular part that you see on the top of the starter motor. Works very efficiently. Takes many, many thousands of times to wear out a solenoid. The solenoid contacts, closes, and allows the current to flow directly from the battery to the starter motor. It also engages the pinion gear to the ring gear to turn the engine. So if you think of a car that may be only a couple of years old or maybe 10 years old, how many thousands of times has that action happened in starting that motor? Many, many thousands. Basic starting system, there is the circuitry. As you can see, there's no wire. If you look at the starter or ignition switch, they haven't got a circuit running off the run terminal. So where you see the ignition switch, you've got start, run, off, and accessories, which is a normal setup for ignition switch. The run, we haven't got a circuitry on it, but obviously that would have things on it, like certain power to certain areas, maybe a fuel pump, injection system, all sorts of other things. I've got to run while the engine is running and need, in some cases, more power than others. But if we get back to just starting it, basic starting, there's the battery, negative earth. You can see that symbol, and the battery positive taking power straight to the solenoid, to the starter motor. It also goes off to a starter relay and goes to the ignition starter switch. So if you were, or you do, turn the ignition, and that little arrow that's on off would then turn to the start. So it goes through the run switch or past it and hits start. That excites the relay, which then sends the power to the starter motor. Once the motor is running, you release the switch and it automatically, with the spring action, drops back into the run mode and the motor's running. Obviously for ignition and that sort of thing, because when you turn the motor to the off position, what's it do? It cuts out that run circuitry and the motor stops. Okay. Same thing in a diesel, it doesn't need that electrical for the spark plugs, but yeah, we'll get to more of that circuitry. That's the charging circuit, and obviously now you may be getting the idea that there's lots and lots of different circuits running through a car. We've just got the start one, now we've got a charging one. We've got a battery, so we've got to be able to charge that battery to be able to start the car when we turn it off and restart it in 5 minutes, 5 hours, 5 days. Okay, so basic charging, we're using the battery again. There's a negative, positive, and we run it up to a alternator. We've got a voltage regulator. A alternator without a voltage regulator can actually produce quite an amount of voltage, enough that would actually probably dry the battery up. It would cook it, so to speak. It would produce enough voltage that it would heat up the battery, and hence the acid, the water in there would evaporate or be boiled off. So you need a voltage regulator. There's the ignition switch. You've got some information there. When the engine is running, the alternator supplies current to charge the battery. Makes sense, all right? The voltage regulator regulates the voltage within a range defined by the manufacturer so the battery does not get overcharged. That overcharging is what would get rid of the acid or the liquid in there, okay? You've got to be able to adjust that voltage. We're talking about 12-volt battery, so obviously it's going to be around a little bit more than 12 volts. It's usually up around about 12.6, 12.5. We talk about 12-volt bulbs, that sort of thing. So everything runs along that same voltage. Moving right along, a spotlight circuit. So obviously for our four-wheel drive owners, but anyone's going to drive a car, we've got to have lights. Okay, basic spotlight circuit, very similar to a headlight circuit, although you'd find that most times, I'd say 100% of the time, you're going to put the headlights on, you usually get tail lights. Okay, so there it is, the basic spotlight circuit, switch and relay. On the bottom of the relay, you have these numbers, and they usually indicate where they go to. Usually when you buy it, like most things, we get a little diagram or an instruction booklet, what connects to where, and hence the terminals on the bottom of the relay have numbers beside them. So you can see it goes to a 12-volt battery, the switch, and negative. Okay. We need to complete that circuit by using the body of the car as the earth return to the battery. Okay. Let's have a look at the fuses and circuit breakers. So we were talking about that 12 volts, or I said that, you know, the alternator can produce more than 12 volts. You need these circuit breakers or fuses in that area to eliminate something more expensive than well, probably under $1, probably 10 cents each fuse from being blown. Good, powerful spotlights, bulbs, relays, switches, we're talking many dollars, you know, we're talking hundreds of dollars for some very good driving lights. So there's the fuses and the circuit breakers. We've got the lights up the top. We've got our relay and switch. We saw that before. Now we've got fuses, circuit breakers, the protections for the circuit. It gets a little involved. But as you can see, it's only one of many circuits we're going to investigate. Okay, the fuse block is the important thing here. All right, you've still got that positive and negative coming through there. All right, we'll move on to a little more about circuits in the car. Wiring looms, harnesses and body electrical systems. That's pretty scary when you look at a wiring loom like that. Look at all those red parts represent the wiring system. Talking about environmental the other week, we did say that wiring can be recycled. It's usually, stripped and melted down as copper and that sort of thing. I can't imagine how many meters or weight-wise, how many kilos are in that wiring system. In new cars, they are starting to limit that with new systems, but that gives you a pretty good idea of the amount of electrical wire in the car. For running all those items, lights, each one, if it's a four-door car, doesn't matter which door you open, you can have a light coming on, maybe a warning light on the dash, an interior dome light, maybe a light in the door. All sorts of lights and mechanisms can work off just individual doors or a boot or a bonnet. So pretty impressive wiring diagram there. Okay, another very interesting part that we need is fuel pump, basic fuel pump circuitry. Fuel pumps, as we get into talking about electrics and modern cars with and fuel injection systems, most fuel pumps are now merged in the fuel pump, in the fuel tank. The fuel pump is in the fuel tank. So you can see there on the fuel pump in the right-hand lower corner, it talks about the vehicle chassis ground. So it actually has a wire running from the fuel pump to the chassis ground, which runs back to the battery. Okay, there's the relay, the numbers on it again, the fuse, top left, and the relay. And again, that's earthed or back to the chassis ground again. So basic ignition system, this is going back a little bit. It's electronic ignition, so it's not that old. It's what we use today. I thought it was going to be a points one, but it's not, sorry. Okay, up the top, we've got the battery, once again, negative earth, the fuse, the ignition switch, through to a coil. We have coil packs or individual coils now going with each spark plug. This is a one coil which goes to the top of the distributor, and then as the rotor turns, which is that red, indicated by the red triangular piece with copper piece coming out of it, as that turns in the distributor, it distributes the power to the plug wires which distribute to the spark plug. So if we have a bit of a quick read of it, primary wires are low voltage, they have thin insulation and skinny. Secondary wires have more insulation to resist the high voltage. Secondary wires much thicker than the primary wires. So they're referring to the primary wires are those ignition switch wires, the ignition module, and then where it gets to the secondary ones, the coil wire and the plug wire. Troubleshooting, back to our great multimeter. I think 99.9% mechanics now own their own multimeters. Over the years, they've come down in price. They have them in very rubber little insulation boxes that they can drop them and just about run over them with the car, and they do last. So the multimeter there, measuring again. It's on the negative, it's on the positive side, it's on the negative of the battery, and on the positive side of the power, okay? 12 volts, it's measuring it. As we saw before, the switch would have to be in a closed position, right, to allow the power to flow. So it's pushed to the right there, that would represent closed circuitry, okay? Measuring current in amps. Did I jump a slide there? Sorry, no, I didn't. My mistake. Measuring current and amps. Once again, this is a multimeter, and as I said, that's why they're multimeters. They can measure amps, volts, or ohms. And that's exactly the same picture as we had before with the amperage going. We can reproduce this. We have some multimeters. You can have a go at in the workshop, experiencing this, turning the lights and dims off. That's bad. The phone went off. Okay, on to the next module, on to the next slide there, sorry. Measuring resistance. Carbon composite resistor. We won't go into what they're used for, but using that multimeter again, there we have the ohms being measured. As I said, got the positive, negative leads of the multimeter. Insulation on them, small steel pointers. Yeah, they're sharp. They'll dig into wiring insulation, allows you to read ohms, voltage by amperage. Using a test light. Now, this is a very common tool and quite inexpensive, quite easy to use. And all it does, instead of giving you, it's not, the only thing it doesn't do, it doesn't measure resistance, but it allows you to see if there is a voltage or amperage there, to see if the circuit is working, i.e. when the circuit is complete and open, is closed, then the light's going to come on. If you turn the switch to open, the light will come off. So a test light could just go straight across the terminals of a battery and light up. You can use them in longer distances than that. They're usually used around areas where the probe positive can just touch something and you can see if there's power there. So it's touching the screw head of a terminal. Very inexpensive, very handy. A lot of guys carry them. Okay. All you need to do now is do your assessment. So I'll leave this with you. You would have had information on how to do the assessment. You'd have information on question and answer times. Pretty straightforward. Best of luck with your assignment. Thank you and bye for now. Be safe. That's funny.